Hi there, welcome to my class on the graph of periodic function. So here we'll see that how the graphs of sine, cosine and tangents can be drawn or sketched on a graph or on a plain paper. So actually we'll talk about the sketch of the periodic function. And in addition to the graphs of simple periodic functions, we'll see that how the rules of transformations apply while drawing the graph of those functions with some linear combinations with constants. And in addition to those sketches, we'll also see that how the periodic equations can be taken taken out directly from the given graph or sketch of the periodic function. Okay, guys. So we'll first see the graph of sine x and its period and amplitude. That means what is called its period and what it is and its amplitude as well. So here our function is y equals to sine x, and all these values are in radians. If you like, you can put these values in degrees also. So here this is 0 degree. If you say this is in degrees, and pi by 2 means 90 degree, and this is 180 degree, and similarly up to 360 degree from either side of this 0 degrees. But here, or in general, we take the values of this angle in radian. So when you are using the calculator, make sure that whether you are using this sort of thing in degrees or in radian. If this is written like this, that means this is definitely angle is definitely in radian measure, and that means you have to fix your calculator in radian mode. Otherwise, if you put here degrees, then you have to put your calculator in degrees mode. So here you know that from your previous knowledge that sine 0 degree or sine 0 radian is 0, and sine pi by 2, that is 90 degrees 1, and sine pi, that is 180 degrees is 0, and 3 pi by 2 value, if you put in calculator in radian mode, you will have this value as -1, and then this is 0 again, and from the left side this value will be -1, 0, +1, and this is 0 again. So you can use your calculator if you don't remember these values of angles for sine. All right. And now, as in simple graph, we'll just put some standard point over here. So you have to draw the x-axis and y-axis line like this, and then you have to scale according to what you have here. So here in this case, you can see that if you cogitate on the values of sine x at these angles, then you'll see that there are only three values, 0, 1, and -1. So you can say that, or you can just assume that your maximum value is +1 and the minimum value is -1. So here at sine 0, it is 0. So you can cross mark like this, or you can write a dot mark. And at pi by 2, the value is 1. So you can see along the y-axis, because the maximum value is 1, I have taken this up to 2 only. Otherwise, you can leave it up to 1 only. And then again at pi, this is 0. That means your curve goes like this. The curve goes like this, right? And don't be hurried to draw the smooth curve, first of all. And then after 3 by 2, its minimum value is -1. That means it's over here, and then it goes like this. Okay, so just try for a reference line only in the beginning, and then as soon as you reach 2 pi, the curve goes towards 0 values again for y, and it will run like this. And then now you can smooth this curve like this. That means the sine curve is ready in between uh, angle 0 and 2 pi. And the similar work you can do to the left side of this y-axis. So, all right. So your sine curve is ready over here. So you can see that if you talk about domain of this curve as domain means we talk for the range of values along x-axis. That means it is from, we have not fixed the angle value over here, so therefore it is from negative infinity to positive infinity, right, in the small bracket. And if you talk about the range for this curve is, range means maximum and minimum values along y-axis. So minimum value is -1 and the maximum value is +1. And you can see that -1 and +1 um, both are included at this point and at this minimum point. So we use big bracket for this. All right. So this is the curve for sine x if the angle is x. And now we shall talk about period of this sine x. So what do you mean by period? Period means something happens periodically, uh, that is at some equal interval of time. The things if get repeated with equal interval of time, then those sorts of things are actually periodic. For example, there can be periodical. So here you can see that you start from 0, then the curve goes towards the maximum value, maximum turning point, then it again returns to 0 point, and then it goes towards the minimum turning point over here, and then it rises again. And similarly, you can see that from here to negative pi by 2, it goes towards the minimum turning point, and then it reaches 0 point, and then again it goes to maximum turning point at negative 3 pi by 2, and then it returns back to 0, and the things get repeated every after. You can see along the x-axis from here to here the distance is 2 pi. So, and also from here to here the distance is absolutely, this is 2 pi. So negative sign is due to the change of direction from this y-axis towards left. All right. And as we are talking of domain between negative infinity to positive infinity, that means your curve will not stop here only. It keeps on repeating like this up to here. Up to here it will be 2 pi, and then again from here it will repeat like this, same repetition. So from here to here again, if you measure this distance, it will be 2 pi, and therefore you can say that the period for sine theta is, or the period for sine of given angle, here it is x, is 2 pi. All right. Periodical uh, by taking the maximum point, that means maximum y I am talking of, maximum y plus absolute value of y minimum and divided by 2. That means it is y maximum, you can see here, this is 1, and plus absolute value of y minimum is here -1. So it is -1 and divided by 2, so that it is 1, and absolute value of -1 is again 1, and then divided by 2. So this is 2 divided by 2 equals to 1. So we can say that the amplitude of the given sine curve is 1. 1 means about the line y equal to 0, that is about x-axis, it is 1 unit up and another 1 unit down from this. We are at the positive side, so the maximum value of this resulting curve will be sine 3x. Resulting curve sine 3x will be at pi by 6. So it is pi by 6. So we mark over here the maximum value. All right. Then 0 occurs at 0. Okay. We mark here. And then it is -1. The minimum value occurs at x equals to negative pi by 6. So at this point, it will be the minimum value. And now what happens if you move further? So it is 0 at pi, then now it will be 0 at pi by 3. So one part of our curve is going to be ready like this. So don't make the smooth graph in the beginning. So first of all, just outline it, just make the outline for this. And then at 0, it will pass through 0 again. And then minimum point will be at x equals to negative pi by 6. Then it will go like this. And 0 again towards the negative number is, it is at pi it is 0, it should be 0. Okay. So at pi by 3 it will be 0, then it will pass through pi by 3 again. And towards the positive side along the x-axis, this is 0 point at pi by 3. Now -1 occurs at 3 pi by 6. So 3 pi by 6 is in fact pi by 2 here. Okay, so pi by 2 means it will be here. And then it will be 0 again at 2 pi by 3. So 2 pi by 3 is here. So your curve will repeat like this. So what did you observe here? Here in this case, as you have seen that as x has been multiplied by 3, the curve has now been shrinked more towards, shrinked along the x-axis by 3 unit. That means if period of sine is 2 pi, all right, then the period of sine is 2 pi. That means the period for this sine 3x has decreased by or shrink by 3 units along the x-axis or towards the origin, you can say, and then this will be divided by 3. Okay, so period for this curve is pi by. In general, you can say period of sine, suppose that any coefficient time of x will be given by 2 pi by b. It's okay. So in this way we can find the period. What about the amplitude of this sine curve? Okay, amplitude means we talk about the maximum and minimum value. So you can see that the maximum about y equal to 0 or about x axis is maximum value is +1, and the minimum value is -1. So we take, so maximum value is +1 and the minimum value is -1. So we have amplitude as +-1, but we take absolute value of this thing, so that the amplitude is 1 in this case. So even though the period of this curve has changed, but the amplitude remained the same when we have made change in x only, not in entire y. So note it down. And also, if you like to check the amplitude by the formula maximum minus minimum by 2, or also you can say it as y maximum, means we talk about the maximum along y axis. Okay, and then plus absolute value of y minimum divided by 2. That means it is y maximum is +1, you can see, plus y minimum is -1. So under the absolute value -1 divided by 2, and then it is 1 plus absolute value of 1 is 1 divided by 2. So 2 divided by 2 is 1. So amplitude for this curve is 1. 1 means 1 unit above the line that divides the given curve exactly into two halves, which is here y equal to 0 or x-axis. So amplitude 1 means it is 1 unit, maximum point is 1 unit up and the minimum point is 1 unit down. So 1 indicates both positive and negative values. Here -2, anything. So if you are, even if you are talking about y equal to 0 line, so the maximum and minimum points are halfway between the line y equals to 0, that is x-axis. So if you apply this sort of idea to find the amplitude, you can again see that the amplitude is 1. So here I am talking of amplitude equals to, either you remember maximum minus minimum by 2 or maximum plus absolute value of minimum value. Maximum and minimum means we are talking of maximum along y and minimum along y axis. So here amplitude is y maximum plus absolute value of y minimum divided by 2, and you can see that y maximum is again here. So this is the graph of y equals to sine x by 2. So still this maximum is 1, so we can write here 1 plus minimum is -1, you can see. So you can write here -1 divided by 2, and then 1 plus absolute value of -1 is 1 and divided by 2. So this is 2 divided by 2, 2 to cancel out. So the amplitude is 1. So remember to find amplitude in two ways, that one by observation, another by the formula that we developed in order to find the amplitude of the given curve. Well guys, we are talking of change of period. Now we talk about change of amplitude for sine. So let's consider one example of the sine equation y equals to 2 sine x. So we take as usual the standard values for the sine angle, and then we find the values of sine x at that value of the angle. So our table is like this, but at this time we don't have y equals to sine x. That means we are not going to make any change in x, but we are going to make change in this entire y by taking here 2. It can be 3 also, 1 by 2 also, but I'm taking as an example y equals to 2 sine x. So if is negative, sine x is -1, that means if you multiply by 2, then it will be -2, and then it will be 0, it will be 2, and it will be 0 again. So what happens in this case, that uh, at pi by 2 it is maximum at 1, sine is maximum, sine x is maximum, this is sine curve. So sine x is maximum at x equal to pi by 2, but now at pi by 2 the maximum value for 2 times of sine x is now over here. All right, so your curve will be like this. Curve for this 2 sine x will be like this, and it will pass through pi, because at pi it is again 0. At 3 pi by 2 sine x is -1, but now as you multiply it with 2, the entire y equals to sine x, then the minimum value will be now this. So your curve will pass this way, and at 2 pi you can see it is 0 again, so it will go like this. And similar thing happens here. At 2 it will be here, and then at pi it will be x is ready. Note that here we did not make change in x, but we made change in y. So when it was sine x, now it is 2 sine x. Then what happens? The period remains same, but the amplitude has now changed. So here you can see the period is still, it is 0 up to here half circle, up to here it is complete circle, then another circle will keeps on will keep on repeating. So the period is 2 pi in this case, and the amplitude you can see, amplitude is maximum is 2 and minimum is -2, so amplitude is 2. Okay, and in general, if you would like to find amplitude by using formula, or if you would like to test the formula, so it is maximum of y plus absolute value of y minimum divided by 2. So let's see here that y maximum is 2 and the y minimum is -2 and divided by 2. That means it is 2 plus 2 divided by 2, and this is 4 by 2 is 2. Okay, that means the curve oscillates between positive 2, oscillates between -2 and 2. Furthermore, we talk about translation of sine curve by translation vector a0 or negative a0. A is constant, it can be either negative or positive. So as our angle of interest is x plus 2, we take the standard values for x plus 2 as in we have taken in sine x. So here the standard values for the angles are 0, 90 degree, pi, 3 pi by 2, 2 pi, and similarly towards the left side of this origin, all these values are negatives. Okay, but what happens if your standard angle is x plus 2 equals to 0? It means if it would be x, it will be -2. Okay, so 2 unit left, 2 units shift to the left. Similarly, if your x plus 2 is equals to 3 pi by 2, for example, sorry, x plus 2 equals to 3 pi by 2, then x will be 3 pi by 2 minus 2. That means 2 units left along x-axis. All right, as the period for sine x is 2 pi, so here there is no change in period because it has only shifted with the same shape towards 2 units left. Therefore the period for sine x plus 2, that means y equals to sine x plus 2, is still this is 2 pi. Okay, what is the change in the amplitude? Can you see any change in the amplitude? Still the amplitude is the same. There is no change in amplitude because we didn't change the shape of this graph. Only the graph has been shifted 2 units left along the y-axis. That's why there is no change in period, and also there is no change in amplitude. So amplitude is again still it is between +1 and -1. So we write amplitude equals to 1. It's okay. So there is a general thing that sine x plus minus a, for a is positive number, for example, greater than 0, we'll talk. Okay, so we have already seen that if it is x plus 2, then it has 2 units shift towards left along x-axis. If that will be minus, then you'll see that there is no change in amplitude and the period of the graph. There will be only the shift of 2 units, or here shift of a units towards positive direction in along the x-axis. You can see this is a very important example in the translation, that is the transformation of graph along y-axis. We have seen the transformation, that is translation along x-axis. Now we'll see that transformation along y-axis. So the topic is transformation, that is translation of the sine curve we are talking of by a translation vector 0b. That means there is no change in x, but there is change in y by number b. It can be either positive or negative. So let's take an example. Y equal to sine x plus 1, you can, or you can say 1 plus sine x, then x value of this we take as usual in the standard form, and then sine x values are like this, and plus 1 means what happens? If it is 0, then it will go 1 unit up, that is 0 plus 1 is 1, 1 plus 1 is, this one is 2, 0 plus 1 is 1, -1 plus 1 is 0, and like this. And in the green color you can see that this is a graph of sine x. Now what happens actually? At pi by 2 you can see the maximum value is 1, but now because of this plus 1, it has gone 1 unit up, so maximum value now became it is 2. And the minimum value you can see in the sine curve is -1. So -1 plus this +1, it is 0. So it has become now 0. So here you can see that the maximum value is 2 and the minimum value is 0 in each case over here. All right. So in this way, what happens actually, this whole thing you can suppose as the y, and then in y you have added any number 1, it has gone one step up. Can you guess if that would be negative value? It will go one step down from this x-axis. So I have drawn this line. This line is actually y equals to 1, because the things that happen from here, that means this origin has shifted to y equals to 1 over here. So same properties of the sine curve will be shown about y equals to 1 instead of at about y equals to 0. Okay. So what happened to the period in this case? You can see that there is no change in shape of the graph. So it has just gone shift up. Okay. So period is still the same. That means period is 2 pi. But what about the amplitude here? Amplitude means, by observation from the graph, you can see that the minimum value is 0 and the maximum value is 2. And about this dividing line, you can see that this is 1 unit up and this is another 1 unit down. So its amplitude is still 1. And this can be evident by using this formula also. So maximum y is 2 in this case, minus the minimum y is 0 in this case. Or you can make sure that at this point we'll take the difference of maximum y and the minimum y, not like maximum y plus absolute sine of the minimum y value. Why it is, we shall discuss in the next class. You can write plus absolute value of minimum y and divided by 2. So this is 2 divided by 2 is 1. So amplitude has also not changed in this case, because there is no change in shape of the graph. It has just shifted 1 unit up. And now one more important thing about this sort of translation along y-axis. So how we can get this value 1? We have another formula that we can see practically from this graph. So you know that y equal to 1 or y equals to 0, whatever, these are the line about which the curve gets divided into two halves. So this is at the mean position of the curve between maximum and minimum value. So maximum and minimum occurs here about x-axis, but here it occurs about y equals to 1. So this one must be in between this maximum and minimum value. Therefore, y shift will be given by the midpoint of y values for the maximum point and the minimum point. Therefore, we have the formula like, if you can say this as C also. Okay, it's like C. So you can write C equals to maximum, that means y maximum plus y minimum divided by 2. All right, and y maximum, you can see this is 2 and y minimum is 0, and divide by 2, so it is 2 by 2, it is 1. So in order to find the value of C, what you can do, you can take average of maximum y and the minimum y. You will have the value of C from the graph. Now we'll see how to find the graph of sine inverse x. Okay, and in your transformation chapter, you have seen that if there is a line y equal to x, and this is a curve, for example, any curve y equals to fx. All right, then in order to find the graph of f inverse x, you don't need to take the points like this or any other reference. Just you take reference of the line y equal to x, and it has been found that the inverse graph is reflection of the given graph about this line y equal to x, as plane mirror. So in the plane mirror, its image will look like something like this. Okay, and then it will be the graph of f inverse x. So what happens here? If it is AB value, then here it is BA. All right, and same thing occurs at every point on this reflected image of this graph, which is inverse of the given graph y equal to fx. And the same strategy we'll use over here. So you know that this is the sine curve, and this we have already seen that how to sketch the sine curve. And now gently you take a line y equal to, if you are interested to find the graph of sine inverse x, you take the line y equal to x, and x will be x will act as the plane mirror for the part of the graph. So about this line, you can see that image of this graph is like this. So what happened here, it is pi by 2 1, then this point will be 1 pi by 2. That means x and value will get reversed. Okay, and lower portion of this graph will reflect like this. All right, so if as this point is, you can see that negative pi by 2 negative 1, then the xy value will get reversed, so it will be negative 1 and negative pi by 2. So this in the dark color is the graph for y equals to sine inverse x. But one important thing you have to remember that, so in order to find the inverse of sine x, that means we are finding the inverse of this function, and you know that inverse is possible only when the function is one-to-one function. In that case, you test the horizontal line by horizontal line test. So about this portion of the graph, if I'm talking, and if I'm taking the horizontal line test, it crosses the graphs at 2 points when it is parallel to the x-axis. That means for two values of x, there is only one value of y. It means between between x equals to 0 and pi, the given curve is not one-to-one function. So between these two values of x, the inverse is not possible. All right. So in order to find the inverse, the function must be 1 1. That means if I'm talking about x as less or equals to pi by 2 and greater equals to negative pi by 2, and any parallel line test, you see that it cuts the curve only at one point between x equal to negative pi by 2 to x equal to positive pi by 2. Therefore, for the domain negative pi by 2 and pi by 2, the inverse is possible, and only then we can do that sort of thing. So usually, unless otherwise stated, if you'd like to find the graph of the inverse of sine x, then you take only between these two lines. So it is pi by 2, it is negative pi by 2, and it will be the graph for sine inverse x. Okay, so in any other range between 0 and pi, because it failed the horizontal line test, so the inverse is not possible. Yes, in between x equals to pi by 2 and 3 pi by 2, the inverse is still possible here. It's okay. And instead of this y-axis as the reference line, you have to take uh, x equals to pi parallel to the y-axis as the reference line. And in this case, again, you can draw a line like y equal to x, and then you can find the inverse of sine by taking reflection over this line. It's okay. So usually this sort of work about origin is enough to say, or enough to show the graph of sine inverse. In today's class, at last, we shall discuss about one thing that is being taught in A2 mathematics, pure mathematics A2, that is paper 2. All right, this is not needed in paper 1, but this is important to discuss on the graph of the reciprocal of sine x. Okay, so let's take the standard values of x and then sine x values. You know that it will be like this, and 1 by sine x means 1 by 0 is infinity. If it is 1, so 1 divided by 1 is 1, and 1 divided by 0 is infinity. 1 divided by 0 is infinity, you know that. So where it is 0, it is 1 by sine x, that is cosec x is infinity. When it is positive or negative 1, the 1 by sine x value, that is cosec value, is values are the same. So let's take now this sine curve as the reference curve. Now you can see for 1 by sine x, uh, the curve goes towards negative at x equal to 0. That means this is one line of asymptote. And again it goes towards negative, it goes towards, infinity at x equals to pi. So x equals to 0 and also x equal to pi are the line of asymptote for y equal to 1 by sine x or y equals to cosec x. Okay, then what happens here at this point at pi by 2, sine x is 1 and both are 1, but in between 0 and pi, it will, when uh, the curve goes near and near to x equal to 0, it will be infinity. That means it will go near and near to y axis but never touches the y axis. And similarly, about right from this point, okay, that means from pi by 2 to pi, at pi it is again negative, so it goes near and near to the line x equals to pi but never touches this line, and hence it has x equal to pi as line of asymptote. Okay, and similar thing you can see at x equals to 2 pi, it is again negative, and x equal to pi, this is x equal to 2 pi, it is negative infinity, you can say. And also at x equals to pi, it is infinity, so from towards negative. So in this way your curve will be like this. So similar thing happens here, so you don't need to draw the line. Now this is understood. So your cosec x curve will be like this, and it will be like this. Okay, so this is a graph for y equals to cosec x, or you can say that this is the reciprocal of sine x. All right. Okay. At last, can you now try the following graphs? So it is, you can see y equal to sine x. X has become now negative. That means you have to draw the sine graph and then reflect the graph about y-axis. Here you can reflect the graph about x-axis if it is minus sine x. And once we have done these two works, check whether the graphs of these two equations are the same or different. If it is same, then analyze that why the graphs of these two equations are, or these two functions are the same. The similar work you can do over here, and here you can put minus 3 and sine minus x. So this important thing is that first you draw a reference graph of sine x, and then you draw this graph by taking the, or by considering the rule of transformation, and then see that how the graph appears and what you can get it from your sketch. Similar work you can do for this and this. And then what about their periods and amplitude also you have to see in each case. So here, once you have sketched the graph of each of 1 to 6 by hand, okay, first of all everything we will do by hand, then go to a graphic software, for example Desmos Graph or GeoGebra, and then check whether all of your works are correct. And then you may try the similar works for cosine graph also, that I'm also going to present you in the next class. Today we did by hand manually, but tomorrow we'll do the same work for the cosine function, and also we'll sketch the graph of the sine and cosine function, and we'll see that in Desmos graph how we apply the Desmos graph to check whether our work is correct or not. In your exam, you are not allowed to use any graphic software, but while in practice, this is good idea to be familiar with the graphic softwares like Desmos Graph, GeoGebra, or any graphic calculators. This is important to understand, or especially when you want to check your work whether this is correct or not. It is most important. It is very important to go through the graphic software. So this is all now, and thank you for your patience for today.